That's all right.
Sure.
All right, so this is what we talked about, right? So this is a filtrate. So this is kind of the flow. So as this filtrate basically accumulates in the Bowman's capsule, it moves along to the proximal convoluted tubule.
Okay.
Yeah, so the parts, so we got proximal convoluted tubule. This is the loop of Henle. So this is the descending loop, because this is the direction of flow, right? So we're going to go down first. So descending loop, ascending loop, and then we have the distal convoluted tubule and the collecting duct. Yeah. Okay, so in the proximal convoluted tubule, we have, and when I draw things going out and in, it usually is going, if it's going out of the nephron, it means it's going into the capillary.
Okay.
And if it's going into the nephron, it's coming from the capillary, or from the interstitial space, okay? So the proximal convoluted tubule, we've got water leaving, and we've got solutes leaving. And solutes can be anything that's not water, basically. Sodium, potassium, hydrogen, stuff like that. Solutes are leaving, okay?
So they're going into the capillaries, right?
Yeah.
Okay.
Okay, so when we move down, so when we're talking about, so the deeper you go into the kidney, the more concentrated the interstitial space is, okay? And these numbers might not mean anything to you, but these are the numbers it gives you. So, because basically, like right here, this is like the
the cortex.
yeah, cortex and medulla. So, and the medulla. So this is like more superficial, more deep, right? So right here, our concentration is about 300 milliosmoles. It's basically explaining that this is the concentration of solutes in the solution.
Okay.
And then at the bottom, we've got like 1200. Okay, so it becomes more concentrated as we go down. Okay, and the thing about fluids and concentrations is they, like, if a fluid has this concentration on this side of the membrane and this side, they want to have the same concentration on both sides. So it'll adjust to make a concentration. So in the fluid, in the nephron right here, it's at like 300, okay? So it's the same as on the outside, right? Okay. So as we go down the loop.
So you're saying it's like, 300 in the capillaries outside, and then
not necessarily the capillaries.
Like in all of the,
yeah, it's like, yeah. So this is where it kind of gets confusing, because I said this is going out into the capillaries and into the nephron, but in between the two, it's called interstitial space, and that's the concentration in the interstitial space.
Okay.
Okay. All right. So at the bottom of the loop, our fluid needs to be at 1200, right? Because it needs to match the outside. And so as we go down the loop, the fluid in the loop becomes more concentrated. And this occurs by water going out, right? And then solutes coming in.
So it's basically trying to compensate to be able to reach the...
Yeah, and osmosis, right? It always goes towards the higher concentration, right? H2O, solutes. So you can see how that would concentrate it quickly, right? If we're taking out the water and adding solutes, we're going to get to that concentration, right? All right, so once we start going back up the loop, we need to get back towards 300. But one thing about the ascending loop of Henle is that it's impermeable to water. So water can't get out.
Okay.
So can you guess what's the way we'd dilute this if we can't move water?
So, other ions?
Yeah, so the ions make it more concentrated, right?
Yeah.
So if we want to get to a lower concentration, what we'd have to do is take out ions, right? So we're getting rid of solutes, and water is kind of staying in here, right? Because it can't pass
So
through.
just this side is impermeable?
Yeah.
Okay.
So we've got solutes basically coming into the nephron, and specifically hydrogen ion and potassium. And this is still impermeable to water.
Okay.
And then, let's see.
So why are the solutes coming back in at the top then? Are they no longer?
Yeah, this process isn't really driven by, like here it's like osmosis and changes in pressure.
Mhm.
This is more like it's actively being pushed in by transport proteins and stuff like that. Because, so hydrogen ion is basically acid,
Mhm.
and then potassium levels need to be regulated. If there's too much or too little potassium, it can actually cause heart problems and stuff like
Okay.
that. And so this is kind of where it balances out, getting rid of acid, or getting rid of potassium,
Mhm.
and balancing that out. Okay, and then in the collecting duct, we've got solutes going this way, back into the blood. Okay, and then the water then just kind of comes out. Okay. So this example, at least from here, from the distal convoluted tubule on, this is without the presence of ADH. Do you remember hearing about ADH, or what ADH is?
I've heard of it. I'm just like trying to think of what it's called.
Fine. So ADH,
Something lost.
it's anti-diuretic. Yeah.